Hello, so today we're going to look at acceleration and we're going to look at a required practical for GCSE Science. In particular today we're going to look at the acceleration of this trolley. Now by acceleration we mean how quickly is it increasing its speed. If it increases its speed very quickly, it's got a big acceleration and it will go very quickly, very fast. If it's got a slower acceleration, it's going to increase its speed but much more slowly, and it's going to take longer to get to that same top speed. To measure acceleration, we work out the difference in its velocity at the start and the finish, so how much it's increased its speed or its velocity, and we divide that by the time it takes to do so. Now, in the experiment, we're going to pull the trolley with different sized forces. Now, it's fairly obvious that if we pull it with a bigger force, it will accelerate faster. The question today is, if we double the size of that force, will it accelerate at twice the rate? And if we triple the force, will it accelerate at 3 times the rate? Right, well, we've got our equipment here. We've got the trolley ready, and I've got some weights here that we're going to use to pull the trolley along. Now, if I look those over this pulley and leave go, you'll notice that this trolley will accelerate, go slowly at first and speed up as it goes along, and we're going to measure that acceleration. Now, the problem we've got to start with is that if I just take the trolley and roll it, you'll see that it will slow down and stop. Now, that's because of the friction. So what we've got to do before we start is to set up the trolley so that friction doesn't affect what we're trying to measure. We don't want to know what friction is doing to the trolley, just what these weights do when they pull it along. Now, to do that, the best way is to put some books under one end so it slopes down to counteract that friction. So let's just try with one book at the moment. Pop that under the end, and if I put the trolley weights and all on there and give it a little push, it still stops. Needs to be a little bit steeper. So let's put some more books underneath there. Let's try those two. Oops, this time it goes by itself. So let's try it back here. Give it a little push, and it appears to be accelerating. So let's take one of those books out. Fingers crossed. Let's do it a little bit faster. And that's a nice steady speed all the way along. So friction's not slowing it down. Friction is not going to affect our experiment once we start taking our measurements. Okay. Next step then is to take our measurements. So what I'd like to do is to measure how fast it takes to accelerate over a distance of 50 centimetres. So first of all, with it all set up, I'm going to mark out 50 centimetres. And to do that, I've got some of these post-it notes just so it doesn't damage our ramp. So I'm going to place one a little bit ahead of the trolley so that it can start and it's free to accelerate. And I'm going to measure with my ruler exactly 50 centimetres from the start of that, which is not too far. But the problem is, if the weights hit the ground before you get that distance, then it's not going to be pulling over the entire distance, so we need to have them there. So that's exactly 50 centimetres from the start. I'll place it that way around so it's easily seen. So we're going to measure the time that the trolley takes to accelerate from that point in line with there. Now I'm looking at this exactly in line with the start. Now from the camera position, that won't quite be so obvious. This one will be a little bit more obvious at the finish line. So we're measuring it when it gets to the start of this one here. So we'll start the time now and stop it when it gets to there. Okay, first measurement. I'm going to start with 2 of these weights. Each weight pulls with a force of 0.1 newtons. So with the hanger and one weight, that's 2. That's 0.2 newtons to pull it. So that's our first measurement. I've got the timer. I'm going to place it there. Now if you're doing this yourselves, you maybe have one person measuring in line with the finished result with a stopwatch and somebody else releasing this. So a good technique is to count down 3, 2, 1, go, and you start the stopwatch, release the trolley at the same time. So 3, 2, 1, start, stop. And I recorded that as 2.20 seconds. So we'll put that down in our results table, and I'm now going to repeat the same measurement adding 2 extra weights each time. So the second time it will pull with a force, we've now got 4 weights, so that's 0.4 newtons pull, and we'll take the same measurement again and keep repeating that until we've got 1 newton pulling that. We'll put all those in our results table. So that's the easy bit. The challenge is to measure the speed, or the velocity I should say, that it's going at the end. Now, from earlier work you might know that speed equals distance divided by time. So I need a short distance and measure the time it takes to go this distance. I'm going to measure 10 centimetres either side of the finish line so that the average speed of this distance will be what it's doing at the finish line. So, ruler again. This time I'm going to place that one at 10 centimetres to the left, and I'll place this one 10 centimetres to the right. So we're starting the time here, we're finishing the time here, and that will give us the time it takes to go 20 centimetres at the finish line. This is perhaps impossible to measure with a stopwatch, so we'll give it a quick go. This is with 0.4 newtons on at the moment I've got, so we started at the same place, 0 my counter. I'm going to start there, stop there, and see how we get on. Start, stop. Very quick, very hard to manage. A good way around that is to, if you've got slow motion feature on your phone on the video, you can use that. And my advice would be to get the slow motion on your phone, put the timer in there and just set it going. Doesn't matter if it starts at 0. And then video it on slow motion. So I'm going to start the video and release the trolley at the same time. Go. And stop. I just carried on filming. I would normally make sure I've got this in full shot so that I can then play the video back frame by frame and see the time that it reaches this point and the time that it reaches that point and take them away to get the exact time. So I'll then have the time it takes to go that distance, and I can use speed equals distance divided by time to work out how fast it was going at the end. I'm then going to put those values together in the table, again measuring for each of the different forces pulling, 0.2 newtons, 0.4 newtons, all the way up to 1 newton, and record those in my table. I'm going to use those values to calculate the accelerations. Okay, so the question is, how are we going to use those measurements to work out the acceleration of the trolley? Well, it's a 2-step process. First of all, we need to work out how fast it was going at the end of the run. So it started from rest, it sped up to a top speed, and that's our increase in speed. Now we measured the time of the last 20 centimetres, on 0.2 of a metre, and we're going to work out the speed for that section at the end. We're going to use speed or velocity is distance divided by time. The distance for all of these trolleys was 0.20 metres. We've got to have it in metres to get the speed in metres per second, so 0.2 metres rather than 20 centimetres. I'm going to divide that by the time it took to do those 0.2 metres, which was 0.48 seconds. Oops. And that works out as 0.42 metres per second. We've not put the metres per second there because it's already at the top of our column. So we've just put the number in. It makes it simpler and easier to read. Once we've got that velocity, we've got the increase in velocity because, it, as I said just before, it increases from rest up to 0.42 metres per second. It took 2.2 seconds to increase to that speed. So we're going to use our second equation, acceleration equals the increase in speed divided by the total time to speed up to that point. So that was our first measurement. So put the numbers in, we've got this speed that the trolley was going at the end, or its increase in speed, and we're going to divide that by our 2.2 seconds, and that's going to give us our 0.19 metres per second squared. That's 0.19 metres per second faster each second it was travelling for. And then we're going to work out the rest of our accelerations in the same way. And then we're going to plot a graph, draw a line of best fit, and we can then see how the accelerations depended on the force that we were pulling the trolley with.